Hi, my name is Dane, and today I'm going to show you how you can unify your security operations with Splunk Mission Control. Mission Control brings order to the chaos of your security operations by enabling your SOC team to detect, investigate, and respond to threats from one modern and unified work surface. So with that, let's get started. After finding and opening Mission Control from our app selector, we will start in the Mission Control Incident Review dashboard where all the incidents are aggregated. All these incidents in front of us are the notable events already ingested from Splunk Enterprise Security Cloud. Our investigation will begin by looking into ongoing PowerShell-related security threats that have prompted a call to action within our organization. Our directive is to prioritize any incidents relating to possible malicious encoded PowerShell commands being used. To get started, let's just search for malicious PowerShell incidents detected over the last hour by setting our search filter to the last 60 minutes. Generating this list of incidents, we can find an incident and then use the preview button to quickly gather valuable information about this incident prior to opening it for a more detailed view. Let's now drill into this incident and take a closer look. I'll start by assigning the incident to myself as the owner, just to let others know that I'm on it. It's also quick and easy to update the status, for example in progress or whatever else, just to reflect that I'm working on it. Here within the Response tab, we find a response plan already associated with this incident type. So let's see this response plan in action. In the left panel here, we can see that there are 3 phases in the response plan. Let's just look at the first phase called Initial Triage. Enriching indicators is one of the first tasks we'll perform during initial triage. Doing this enrichment manually is very tedious and repetitive, so the embedded playbook that we see here helps simplify this task, and it can even alleviate a skills gap if one exists on your team. The results are now displayed within the Automation tab. Here you will find a history of the playbooks executed, their completion status, and the specific actions executed. So the Process Analysis Playbook posted its results as a note within the first task. Splunk SOAR found a base64 encoded string and it decoded it. Then it found a second encoded string and decoded that as well. In fact, the second decoded string was a URL with an IP address, and this kicked off a Splunk query to hunt for other hosts within our organization that are communicating with this malicious IP. So it looks like there are actually other hosts communicating with this IP with an awkward destination, so we better get ready to take some further action here. We'll do this by going to the Search tab and running a query for any data containing the IP address. Let's investigate the email data. Our search shows that this email was sent to user Fyodor, and the malicious encoded PowerShell command was found on Fyodor's endpoint. Now this can't be a coincidence. Go ahead and add this event to our Mission Control incident. Here's a view of the incident under the Or Choose from Recent area. Bringing this event into the Events tab, we save time and energy because we don't have to rerun a search from scratch. Plus, it's now available as something that can be automated later. And in reviewing this event, it's evident that user Fyodor was likely sent a phishing email from the malicious IP address we identified, and this subsequently exposed our entire organization to risk. So let's move on to our next task called Review Process Tree. In this task, it's important to call out that tasks can also contain an embedded Splunk search to help simplify our investigations and speed things up for you. So let's simply start this task and launch the search. This PowerShell process launched a child process of hdoor.exe, so we need to find out more about this executable. The top search result for hdoor is from MITRE. It appears that this is malware used to identify open ports on the victim machine. Let's go back here to our task and add this finding to our notes. As instructed in the first task of the second phase, we will click on the play button to automate the data enrichment process. Looks like the MD5 hash in our incident data received a high priority score from VirusTotal and looks to be associated with known malware. So let's jump ahead to take some response actions. To start, let's add the MD5 hash to the block list in our EDR tool. Then, files with this MD5 hash will be blocked from execution on any of our managed endpoints. Next, let's quarantine the device that executed the encoded PowerShell process to limit any further damage. Again, we'll use our EDR tool to run the action that will quarantine this device without having to pivot across multiple tools, saving us time and energy. As another protective measure, we are going to use the Azure AD Graph API to disable this compromised user's account until we get all this sorted out. As a final task, let's update our notes on what remediation and response actions we took so that we have a case history for our management team or for other analysts for future reference. Let's complete our part of the investigation at this point and update the status of this incident to pending. another senior analyst can now review all the case notes and actions taken to determine if there are more complex, covert threats that are lurking in our environment. And now we can move on to work on the next incident. So that concludes our demo, and I hope this helped you understand how Splunk Mission Control unifies investigation and response, simplifies your security workflows with response templates, and modernizes your SOC with automation. Thank you.